Okay, today we're going to talk about solving two-step equations. Now, as we've talked about in the past, these two-step equations, or equations in general, are like math sentences. So what I'm going to do today is teach you a few reading strategies rather than go through a lot of different examples so that any two-step equation that's thrown your way, you can see it for what it is, and hopefully solve it. So let's look at this first equation. 2x plus 3 equals 7. And you might be wondering, Mr. Dussault, why is there a balance on your screen? Well, one way to think of equations is as two things that are perfectly balanced, right? Like they were snapped into existence. Perfectly balanced. So here I'm saying that 2x plus 3 is 7. They're the same thing. But what I want to do is I want to figure out what value of x would make this perfectly balanced, right? What value of x would make this a true statement? So because they're balanced, we can think of it like a scale where I have two x's on this side and 3 1's, right? As you can see, two x's and 3 1's, and that's balanced with 7 1's on this side. So perfectly balanced, right? And now the nice thing about thinking of it like a scale is if you want the scale to stay balanced, if you take something off of one side, then you need to take the same off the other side. Or if you add something to one side, then you need to add the same to the other side. So what could we take away from both sides? Well, we have these 3 1's on this side, and we have 3 1's on that side. So if I take away those 3 1's from both sides, then I'm left with my 2 x's and just 4 1's. And, well, what if you thought about that mathematically, right? What operation is used to take something away? Subtraction, right? Subtraction. So if I subtract 3 from both sides of my equation, 2x plus 3 minus 3 is just 2x, and 7 minus 3 is 4. Okay, now this one's a little bit trickier to understand, but we need to think about it less rigidly and kind of more fluidly. Just let your brain think. Here, I have two x's, so if I want to figure out what one x is, I need to cut them in half, right? I need to divide this side into 2 to where I have 2 x's, right? It's kind of like cutting it in half. Okay, well, what would happen if I cut this side in half? Well, there's 4, so if I section it off into 2 parts, then I would have 2 in each part. So then you could think about it, all right, now if I take away an x, half of what I have, that's the same as taking away 2. And hopefully that's getting you to think, well, if I took away an x and took away 2, then I would be left with x is 2. Or if I took away an x and took away 2, well then it must be that x is equal to 2. Now what do we call that when we take something and we break it into parts, or we maybe divide it into 2 parts, right? So if we're thinking about this mathematically with mathematical, well, we are always thinking about it mathematically, but if we were using operations to describe our thoughts, you would say, well, I divided 2x by 2 and I divided 4 by 2. 2x divided by 2 is 1, so 1x, right, or x, and 4 divided by 2 is 2. So that's one way to think about it, as balancing some scales, right? Let's talk about another way that you could think about this. Given the equation x plus 1 divided by 2 equals 5. What would that be? Well, one way we could think of it is, what if x was a number? Some number. How would I simplify that equation, right? What order of operations would I go through? Well, the first thing I would do is I would add x. So here's my order of operations is I would add x plus 1, right? I would add 1 to x, and then I'd get some number, right? I don't know what that number is, so I'm going to call it a box. Right? And now, okay, what would I do to simplify the left side? Well, I would divide that box by 2. And then box divided by 2 would give me yet another number. I don't know. Right? And really, well, we're saying circle equals 5, so that would give me 5. Okay, if I had the right number for x. So sometimes in solving these problems, it's helpful to think in reverse, right? That's the way that we would have done it if x had been a number. But in order to find x, I need to reverse those operations. So let's think about what it would look like if I reversed the operations here. And notice it's 2 steps, right? A 2-step equation. So then my first operation, instead of dividing by 2, I would, that should be a 1, right? This is my new, I'm going to go down here. So my new, I have x plus 1 divided by 2 equals 5. Now my new order is, instead of dividing by 2, I'm going to multiply by 2. And remember, if I'm doing something to one side, I need to do it to the other, because I'm not combining numbers here. So when I multiply by 2 over here, then I need to multiply by 2 over here so that my equation stays balanced. Okay, so 2 times x plus 1 divided by 2, those 2's cancel out because 2 divided by 2 is 1. So I'm left with x plus 1 equals 5 times 2 is 10. Okay, now instead of adding 1 to x, we're going to subtract 1. Okay, so if I subtract 1 from both sides, x equals 10 minus 1 is 9. And if we were to take that and put it back into our equation here, right? 9 plus 1, so maybe I can, 9, well, let's do it in red. 9 plus 1 would be 10, and 10 divided by 2 would be 5, right? 5 equals 5. So that feels pretty good because we got the right answer. Okay, so that's 2 different ways of thinking about solving 2-step equations, balancing the scales, or going in the reverse order of operations.